Welcome to Terra Firma Resources Advanced Supervisor Training Module. Before proceeding with the presentation, confidentiality must be addressed. The information in this presentation includes information that is to remain strictly within the company. By ascending to supervisor position and by your continuation of the presentation, you are entering in a verbal contract that any information presented here will remain confidential, and is used solely for the purposes of training our supervisors and developing a well-rounded workforce. The confidentiality information displayed on the screen is the same that was signed by yourself upon being hired with the company, and is the legal basis for ensuring that this information does not move past yourself. In this presentation you will be deeply initiated into the following aspects of being a supervisor with Terra Firma Resources. Supervisor responsibilities, incident reporting and management, emergency response plans, hazard identification, assessment, and control, site inspections and tool inspections, supervisor binder overview, driving, monthly safety meetings, competencies and on-the-job training, and quality control. Supervisor responsibilities. In this section, we will discuss the following: understanding your legal responsibilities, understanding due diligence, Section 217.1 of the Criminal Code, and the Occupational Health and Safety Code Book. Your legal responsibilities. In 1976, Dr. James Ham introduced the concept of the Internal Responsibility System to Ontario in the report of the Royal Commission on the Health and Safety of Workers in Mines. The Ham Commission led to the coming into force of the Occupational Health and Safety Act in 1979. The OHSA provides for the establishment and maintenance of the IRS, for example by setting out specific duties and functions for the workplace parties. The IRS has become the basis of health and safety legislation across Canada and defines your legal obligations and duties. Supervisors play an important part in shaping the safety culture of an organization. Your attitudes and actions strongly influence the health and safety of your workforce. Here are 5 suggestions to help you succeed in this role and fulfill your legal duties. Number 1. Be familiar with the law. Supervisors must understand the basic rights and responsibilities of employers and workers described in the Act. Access to occupational health and safety legislation will help you determine your legal requirements for Terra Firma's work sites and activities. Number 2. Know and enforce policies and procedures. Terra Firma's safety policies and procedures have little value if they're not adhered to. As a supervisor, you must not turn a blind eye to infractions and unsafe practices. Number 3. Walk the talk. Supervisors have to be safety role models. You must follow the company rules, policies, and procedures. Excuses like, "I'm in charge," or, "I'll only be in that area for a few minutes," don't justify cutting corners. Number 4. Inform and encourage all workers to work safely. Supervisors who inform their crews about health and safety matters and encourage the safety mindset will have a tremendous impact on the organization's safety culture. Participation in new employee orientations, soliciting employee input for hazard assessments, and personally acknowledging employees' safety efforts are just a few of the many ways a safety culture can flourish. Number 5. Participate in training. Supervisors who attend the same training sessions as their crews will see a positive return on the time invested. They'll gain first-hand experience of the instruction their workforce has received, and they'll see how each employee responds to the training. By being an active participant, you, the supervisor, will also be sending a strong message to the crew about the importance of the training. What is due diligence? Due diligence is the level of judgment, care, prudence, determination, and activity that a person would reasonably be expected to do under particular circumstances. Due diligence is demonstrated by your actions before an incident occurs, not after the fact. Terra Firma has in place written OH&S policies, practices, and procedures. These policies, practices, and procedures demonstrate and document that Terra Firma carries out workplace safety audits, identifies hazardous practices and conditions, and makes necessary changes to correct these conditions by providing employees with information to enable them to work safely. Supervisors are trained to ensure they are competent persons, as defined in legislation. Supervisors talk to new employees about safety and expectations during orientation training. Supervisors meet regularly with staff to discuss health and safety matters. Supervisors inspect areas of the workplace under their responsibility, and respond promptly to unsafe conditions and activities. And supervisors pay attention to routine and non-routine activities, ensuring that employees understand the hazards and the preventative measures to be followed. Terra Firma monitors the workplace and ensures that employees are following the policies, practices, and procedures. Written documentation of progressive disciplining for breaches of safety rules is considered due diligence. Terra Firma has an accident incident investigation and reporting system in place. Employees must report all incidents and near misses. Incidents and near misses with high potential will be investigated. Incorporating information from these investigations into revised, improved policies, practices, and procedures will also establish that Terra Firma is practicing due diligence. In the eyes of OH&S, supervisors are considered employers. Supervisors act on behalf of the employer, and hence have the responsibility to meet the duties of the employer as specified in the Act. A supervisor must ensure that workers use prescribed protective equipment devices. A supervisor must advise workers of potential and actual hazards. And a supervisor must take every reasonable precaution in the circumstances for the protection of workers. Section 217.1 of the Criminal Code. Everyone who undertakes, or has the authority, to direct how another person does work or performs a task is under a legal duty to take reasonable steps to prevent bodily harm to that person, or any other person, arising from that work or task. This bill provided new rules for attributing criminal liability to organizations, corporations, their representatives, and those who direct the work of others. Bill C-45, also known as the Westray Bill, was created as a result of the 1992 Westray coal mining disaster in Nova Scotia, where 26 miners were killed after methane gas ignited, causing an explosion. Despite serious safety concerns raised by employees, union officials, and government inspectors at the time, the company instituted few changes. Eventually, the disaster occurred. After the accident, the police and provincial government failed to secure a conviction against the company or 3 of its managers. A Royal Commission of Inquiry was established to investigate the disaster. In 1998, the Royal Commission made 74 recommendations. The findings of this commission, in particular Recommendation 73, were the movement that led to Bill C-45. Bill C-45 was then passed and became Section 217.1 of the Criminal Code. CBC News, posted on January 11 of 2016. Manager in fatal scaffolding collapse sentenced to 3.5 years. Construction project manager Vadim Kazanelson has been sentenced to 3.5 years in prison for his role in a scaffolding collapse at a Toronto apartment building that left 4 workers dead on Christmas Eve 2009. Kazanelson was aware that 5 of his workers were not wearing safety harnesses, but still allowed him to board a swing stage 13 stories high. It collapsed, causing the men to plummet to the ground. The court heard the work repairing balconies was behind schedule as Christmas Eve approached and that the company, Metron Construction Incorporated, would get a $50,000 bonus by finishing the project by December 31. In another CBC article, an oil sands plant explosion near Fort McMurray leaves 1 dead, another critical. A Nova Scotia man has died after he was badly burned in an explosion at the Nexon Long Lake facility in Fort McMurray. Dave Williams, 30, died Monday in an Edmonton hospital where he was taken with severe burns after the January 15 explosion. Drew Foster, 52, was also killed in the blast. Nexon released a statement confirming Williams's death. "We wish to express our deepest condolences to the impacted families," the news release said. "We remain fully committed to continuing to support the families affected by this devastating tragedy." The company said Williams and Foster were refitting valves on a compressor at the facility, which converts hydrocarbon into a lighter oil. Williams, a journeyman millwright from Scotchtown, Cape Breton, suffered third-degree burns to 90% of the front of his body. His cousin said the family was told that Williams dug himself out of the rubble after the explosion. OH&S ticketable provisions. The government searched the OH&S code to identify simple, observable, and clearly prescriptive violations that could be converted into ticketable offenses. It came up with 66 of them, to be charged against both employers and workers. Tickets impose an immediate $100 to $500 stipulated penalty. Worker tickets range from $100 to $200, while employer fines range from $300 to $500. In many cases, both the employer and worker can be ticketed for essentially the same offense. If a ticket is issued only to a worker, the officer will give a contact report to the employer. The Alberta government has identified high-priority OH&S categories where most of the serious workplace dangers lurk. These include personal protective equipment, fall protection, fire and explosion prevention, equipment safety, cranes, hoists, and rigging, stairways and ladders, biological hazards, and falling objects. While these tickets are not criminal in nature, third parties might be able to obtain a record or abstract of an employer's or worker's convictions for such tickets. This record of ticket convictions may have implications for the employer's safety record and tendering on future jobs. Here are some examples of ticketable provisions. Employers failing to have the required code of practice for chemical hazards will incur a $300 fine. Workers failing to have a valid entry permit when entering confined space will incur a $100 fine. Employers failing to ensure the required MSDS is readily available at the worksite will incur a $500 fine. Employers failing to ensure a derrick or mast logbook is available at the worksite will incur a $300 fine. Employers failing to ensure rope access safe work plan is available before work begins will incur a $300 fine. Workers failing to ensure rope access logbook is current and available at the worksite will incur a $100 fine. Employers failing to ensure workers are using or wearing the required equipment will incur a $500 fine. Employers failing to ensure workers exposed to traffic are wearing the required visible clothing will incur a $500 fine. Workers failing to wear the required visible clothing when exposed to traffic will incur a $200 fine. Employers failing to ensure workers are wearing approved eye protection will incur a $300 fine. And employers failing to ensure workers are using the required protective footwear will incur a $300 fine. Navigating the OH&S Codebook. There are 4 parts to the OH&S Codebook. Due diligence. This part outlines the legal duties under Alberta's OH&S Act, regulations, and code that are imposed on employers, workers, contractors, prime contractors, and suppliers. Act. This part outlines the obligations of employers, workers, prime contractors, and Government Safety Council. For example, to have written health and safety policies, conduct regular inspections of the worksite, etc. This part also outlines the role of OH&S officers. Regulation. This part outlines specific requirements for critical documents to be available, such as the OH&S codebook. This part discusses legal requirements of the employer for items such as maintaining equipment, providing safety training, ensuring workers are competent, etc. It also outlines the administrative penalties. Code. This part is the largest section of the legislation that identifies, in detail, the legislative requirements based on a specific topic, known as a part. For example, Part 2 Hazard Assessment, Elimination, and Control, or Part 32 Excavating and Tunneling.
Went to work for a natural gas company. Went to work in the pipeline department. And I really enjoyed that work. I enjoyed it because it was almost always outside. There was a wide variety of things to do. One day I could be digging a ditch with a shovel. The next day I could be picking charts at a well. The next day I could be welding. I liked that variety. September 20th, 1991. I left with a senior welder Friday morning. We drove to the first location and finished our welding in that station right at break time, right at 10 o'clock in the morning. We were in taking a break, and our company pumper came in. He said he had a well just right outside the location where we were. That well had 2 drip tanks on it. Both of those tanks had a pinhole leak in a well that went around the fire tube. Could we put that on our schedule to fix sometime? The welder I was working with that day, his name is Tracy. At that point, Tracy had worked with the company for 30 years. Tracy said, we'll just fix it today and not have to worry about putting it on a schedule. The pumper said, okay, I'm going to get hold of my supervisor and let him know what's going on. Because of a conflict between Tracy and that supervisor years earlier, and Tracy hadn't forgot it, he said, no, you don't need to get hold of your supervisor. I'm going to do it today while I'm here, and we'll surprise him. We finished break. There was some other discussion that went on. We drove over to the well just right outside the station where we were, and I got the gas monitor out and checked the atmosphere around where we were going to be welding, and it was safe. And I asked Tracy, what's going to keep a spark from getting inside one of those drip tanks? He said the pumper had told him what the liquid level was. It was several feet high. We're going to be welding 12 to 18 inches off the ground. If he happened to burn through the tank while he was welding, the liquid would snuff the fire out immediately. If he happened to go into the fire tube, it's made to have fire anyway, so we'll be okay. What we didn't do was go to the truck, get our tape out, walk up the catwalk, open the hatch, and gauge the tanks to find out for sure what the liquid level was. We assumed that the information we'd been given was correct. It was not. Because we didn't gauge these tanks ourselves, because we assumed that information was right, even though we were the ones on the job, risking our lives, we took information from someone else that was wrong. And anytime you do something to save a few minutes, and that's all we had done, we wanted to save just a few minutes because we'd added this job to an already busy day, it is nothing but a shortcut. That's all it ever will be. And that's what we've done. We wanted to save a few minutes by not having to go up the catwalk, so we didn't engage the tanks. There was not going to be any grinding or brushing for me to do as a helper, so I didn't even put my gloves on. I left them in the truck. Even though I was at a work location where anything can happen at any time, I left my gloves in the truck. I rolled the leads out for Tracy to do his welding. He laid down on the ground, started welding on the first tank. Another supervisor pulled up to see what was going on. I went and talked to that supervisor for less than 30 seconds. Tracy finished his weld on the first tank, moved to the second tank. The supervisor went to get his pickup to leave. I started walking back towards Tracy. The 2 tanks sat side by side. I had walked past the first tank that he had already welded on, and I'd reached a point where I was even with both tanks. I was about 10 feet away from those tanks. I was about 8 feet away from Tracy, laying on the ground welding. And I heard a sound in that tank that he was welding on. I knew it was going to explode. And I hollered at Tracy, it's going to blow. And just then it blew.
Incident reporting and management. In this section we will discuss injury classification, the effect an incident has on terra firma, which includes the TRIF, WCB premium rate, the ability to work for existing and potential clients, cost analysis, and reputation. Procedures and responsibilities, corrective and preventable measures, and an example of a previous incident and safety alert. Recordable incidents are classified into the following categories: medical aid, restricted or modified work, lost time injury, or fatality. All of these incidents are calculated in the TRIF. A flowchart such as this one will help determine the class of recordable incident. Starting at the top, you answer a series of yes or no questions to the questions presented. Once the end of the line is reached, the chart will state what type of incident this was. The incident pyramid shown here demonstrates the level of consequence an incident can have in relation to its frequency. TRIF stand for total recordable injury frequency. The formula to calculate this is the number of recordable incidents, multiplied by 200,000, then divided by the number of man-hours. The 200,000 is a static number that is derived from 100 full-time employees working 40 hours per week and 50 weeks in a year. 100 times 40 times 50 equals 200,000. So a company that does not employ 100 workers steadily for the entire year will really have a TRIF that suffers with even just one recordable incident. When bidding or qualifying for work, terra firma is required to supply their TRIF rating to clients. A poor TRIF that is higher than 2 has a negative effect on our ability to retain and gain more work. This is due to a misperception that a poor TRIF means we have a weak safety program and a potentially an unsafe company that could bring risk and expense to the client. WCB is an employer-funded insurance. However, any claims costs that go against our account are added up and can result in a surcharge, increasing the amount of premiums the company has to pay each year. In addition, terra firma is graded by our clients on our premium rate. If we have a discount, that is seen as favorable as it means that we are more safe and have less incidents or injuries than other companies in our industry. A surcharge means we have more incidents or injuries than other companies and is seen as a negative to our clients. The ability to work for new or existing clients can be affected through incidents, as there are several pitfalls that can affect the relationship. Incidents can decrease productivity on the worksite. The job may also be shut down for a period of time. Expenses related to investigation and reporting for both terra firma and our client. Property damage or site damage causes expense for repair or replacement. Effects on TRIF rating, which has a negative impact when graded by our clients. Effects on WCB premium rate. This can cause a surcharge and is, again, a negative impact when graded by our clients. A useful analogy when considering the hidden effects an incident has on the company is to consider an iceberg. For example, an injured laborer may suffer a back strain and is on modified duties for 6 weeks. On the surface, you see only the small direct impact to the company and the worker, but there are many other factors that come into play as soon as an incident happens. In this case, loss of production on site will occur after the injury happens, which could total $2,000. An incident investigation will commence, which could cost $8,000. A report from the doctor could be another $150. Modifying the work for the laborer for 6 weeks could be another $6,000 expense. The time to attend the worker's appointments could add up to $3,360. WCB premium rate increase could cost $3,800. Hiring a new employee would be $3,600. The total quantifiable cost of this single incident isn't just what's seen on the surface. All of the hidden costs add up to $26,910. With a 10% profit margin, terra firma must do an additional $269,100 in sales just to recoup the cost of this one incident. And beyond this, there are additional impacts that are more difficult to quantify. This includes damage to company image as well as loss of work from existing and potential clients. Procedures and responsibilities. If an incident were to occur on a worksite, you must adhere to the following steps. Stop work. Care for the injured individual or rectify the immediate hazard if able to do so. For example, spill containment. Contact outside assistance if required, such as medic, 911, STARS, etc. Freeze the scene. Notify terra firma resources operations manager. Notify the client supervisor. If required, the supervisor and/or delegate transports the worker to medical facility and stays with them until instructed otherwise. The supervisor ensures all individuals involved fill out the appropriate paperwork, such as an incident report form, witness statement, or vehicle accident report, whichever are applicable to the incident. These should be done as soon as possible. Supervisor to forward the initial reports and all applicable supporting documentation to the operations manager and HSE manager. OH&S reportable incidents. The incidents that are reportable to OH&S only by senior management are as follows. An injury that results in death. An injury or accident that results in a worker being in a hospital for more than 2 days. An unplanned or uncontrolled explosion, fire, or flood that causes a serious injury or that has the potential of causing serious injury. The collapse or upset of a crane, derrick, or hoist. Or the collapse or failure of any component of a building or structure necessary for the structural integrity of the building or structure. Corrective actions and preventable measures. The reason we investigate all incidents is to prevent future incidents. The investigation process determines all of the indirect and direct causes of the incident that allows for recommendations of corrective actions. Corrective actions must be completed in a reasonable time frame and must be communicated to all personnel. In the next few slides, we will review an investigation example for a high-potential line strike incident at a worksite. The summary of events are as follows. On March 23, 2015, a subcontracted HDD company was performing a 116-meter bore under 6 hotlines, a power line, and an access road. The crew successfully crossed the first hotline at a planned depth of 3.5 meters. As the drill bit approached the second set of hotlines, the depths were verified again at 3.5 meters. As the drill proceeded forward, the crew heard and smelled escaping gas. The crew identified a possible line strike and immediately shut down all equipment and evacuated upwind to safety. Access roads were barricaded, the scene was frozen, and the utility owner was contacted. Investigation initiated. Terra Firma Safety and Management arrived at the location to begin investigation. Statements were taken from all present at the time of the incident. The site was inspected, pictures were taken, sketches were drawn, and measurements were taken. Documentation was reviewed and interviews of supervisors were performed. Post-incident drug and alcohol testing was performed. Let's review the sequence of events. On March 13, Hydrovac daylighted the hotlines on bore number 36. On March 23, the HDD contractor met with the line representative and verified the depths of lines. The HDD contractor drafted the planned bore profile and reviewed with the line representative. Drilling commenced. The drill crossed under the first hotline and depths were verified. The drill approached the second set of hotlines and the depths were verified. The drill proceeded forward and the line was struck. So what happened? Prior to beginning the drill, site hole number 1 was opened up using a hydrovac to expose the hotline. At a depth of 1.22 meters, the truck hit hard rock and workers were unable to obtain a visual on the hotline. They tried again, exposing site hole number 2 to 1.25 meters. Again, they hit hard rock and were unable to obtain a visual. They tried a third time, opening up site hole number 3. With this site hole, they were able to fully expose both the 8-inch and 3-inch hotlines at a depth of 1.8 meters. The only difference was they had moved upstream on the hotlines to get away from the hard rock which was blocking their visual. The problem, however, was that this site hole was not on the bore path. With the rock shelf hindering their ability to verify the exact depth of the line along the bore path, the workers inferenced that the line was the approximate depth of 1.8 meters found at site hole number 3. They believed that 3 meters in depth for drilling would be safe. The line being drilled under was old, and workers didn't anticipate that a line would make such a dive in depth in such a short distance. But that is exactly what it did. Decreasing from 1.8 meters in depth to 3 meters in depth in only 8 meters, the line was struck by the HDD drill. Contributing causes were identified and corrective actions were created. These included failure to identify hazard or risk, failure to follow procedures, policies, and practices, failure to communicate, and inadequate preparation and planning. Immediately, a safety stand-down occurred. A meeting was held to clarify roles and responsibilities related to HDD ground disturbance. A new explicit policy was developed, stating that all lines will be exposed and visually verified on the bore path. The client representative and line owner must also be present. Observation and inspection of all HDD worksites took place. And Terra Firma reviewed and revised all safe work practices and job hazard assessments for both ground disturbance and line crossings. Emergency response plans. The company ERP includes all possible emergencies, consequences, required actions, written procedures, and the resources available. This is available in the Safety Manual Section 6, Emergency Preparedness. The site-specific ERP includes project information, including client, location, directions to site, muster area location, location of first aid, type of rescue required, and more. Contact information for client, supervisor, and emergency phone numbers such as the nearest hospital. And basic emergency response procedures. The site-specific ERP must be completed by the supervisor and a copy sent to the operations manager prior to the start of the project. Every vehicle on site must have a copy of the ERP in the driver's side sun visor. Roles and responsibilities of supervisors during an emergency. The supervisor receives an emergency or incident call from a worker. He or she then initiates the applicable emergency response plan. He or she contacts emergency services if required. He or she reports to the client. Then contacts Terra Firma operations manager. It is preferred if supervisor and/or a delegate transports the worker to the medical facility and stays with them until instructed otherwise. The supervisor ensures all individuals involved fill out the appropriate paperwork, such as an incident report form, witness statement, or vehicle's accident report. These should be done as soon as possible. The supervisor forwards all report forms with any other supporting documents to the operations manager and HSE manager. He or she then assists the HSE manager with incident investigation as directed. Hazard identification assessment and control. This section includes purpose of a field-level hazard assessment, proper completion of field-level hazard assessments, communicating and ensuring controls are in place, and examples of previous hazard assessments to show improvements. Field-level hazard assessments. Field-level hazard assessments must be completed daily for all field-related tasks so that hazards are identified, analyzed as to the risk potential, and adequate controls are put in place to mitigate the risk associated with the hazards. Assessment is to be modified or reviewed when new workers, personnel, or contractors come on site. The scope of work changes, such as plans being modified or substitute equipment is provided. If any conditions on the worksite change, such as weather or availability of tools. Whenever you change work tasks or equipment. Or whenever a change in another person's activity on the worksite could pose a risk to you. The hazard assessment must be filled out and signed off by affected personnel, including subcontractors. To complete an FLHA. 1. List the tasks to be completed. 2. Look around and identify hazards. 3. Rank the potential risk and rate as low, medium, or high. 4. Identify and record the controls to be implemented. 5. Implement controls. And 6. Proceed with work. Here you can see an example of Terra Firma's field-level hazard assessment form. Risks are categorized as low, medium, or high using the matrix. Based on the probability of an incident happening in comparison to the severity of the outcome if the incident were to happen, you are able to determine the risk level for your FLHA. Supervisors are responsible to ensure that hazards present on sites have controls in place. Controls must be communicated to all personnel on that worksite. There are 5 types of hazard controls that can be implemented with varying levels of effectiveness. This is the hierarchy of controls. The first and most effective control measure is elimination. If you can remove the hazard from the workplace, then this is by far the best method of hazard control. You can also substitute, meaning for example, replacing a hazardous chemical, work process, system, activity, or material with a less hazardous one. The next control level is engineering. Some examples of engineering controls include the general design of the plant and the equipment, the installation of additional lighting to provide adequate illumination, and the use of instrumentation, automation, or other mechanical devices. The next control is one that is used most extensively in the workplace. Administrative controls can include things like permits, authorization procedures, operating procedures, safe work practices, restricted areas, training, and more. PPE is the last line of defense, and is used when other controls are not possible or additional protection is needed. It is important to remember that PPE does not remove the hazard, it only inserts a barrier between the worker and the hazard. Process and responsibilities. An inspection is an observational tour of the site and tools to check for compliance with regulations, safe work practices, safe job procedures, and safety rules. When completing an inspection, examine all aspects of the workplace, including people, physical conditions, environmental, equipment, materials being used, and actions taking place. Look for any potential hazards, existing hazards, or violations of safety rules, regulations, and/or code. Any deficiencies observed during the site or tool inspections must have corrective actions. Corrective actions must be completed within a timely manner. Corrective actions must be communicated to personnel through morning tailgate meetings or monthly safety meetings. Supervisors are required to complete at least one documented worksite inspection per week or per job. Driving. Driving is the most dangerous part of the job. When driving, always assess the hazards on a daily basis based on the conditions at the time. Drive to road conditions and be aware of wildlife. Pre-trip inspections are to be completed for all vehicles and equipment prior to starting any work. Pre-trips must be handed in at the end of the week to your supervisor. Any defects on the pre-trips need to be corrected, preferably by the mechanic within a timely manner. Corrected defects must be recorded on a work order and attached to the pre-trip. There are two types of defects for commercial vehicles. Minor defects. The driver is allowed to operate the vehicle or trailer with minor defects present, but all defects must be repaired prior to the next required trip inspection or trip's end. That is why the trip inspection report now requires the location of the inspection and the time of the inspection to be recorded. Major defects. Vehicles are not to be operated with a major defect present. When a driver identifies a major defect on the trip inspection process and/or the en route inspection process, the driver must not drive the vehicle, and the carrier must not instruct the driver to drive the vehicle or trailer until the major defect is repaired. All cargo must be secured properly to prevent accidents and be in compliance with legislation.
It seems straightforward enough, fastening a load of equipment down securely. Just throw on a few straps or a couple of chains and away you go. Unfortunately, a piece of poorly fastened equipment, chunk of ice or clay, or weak chain or strap can result in your worst nightmare. Whether large loads or small, as the operator, you need to make sure what you're hauling is secured correctly. It's the law, and the fines for sloppy or incorrect securement can be a shocker. The buck always stops here with you, the operator. On the road, you're ultimately responsible for the lives and safety of the people around you. The vehicle you drive and the items you haul have the potential to cause injury, death, and destruction. The responsibility for making sure this doesn't happen cannot be taken lightly. And the list of items that need to be secured correctly is extensive. According to the North American Cargo Securement Standards, this includes all items that could leak, spill, blow off a vehicle, fall from a vehicle, fall through a vehicle, become dislodged from a vehicle, or shift upon or within the vehicle to such an extent that the vehicle's stability or maneuverability is adversely affected. In other words, everything you're hauling, whether it's in a van, a pickup, a trailer, or a flat deck, needs to be properly secured. And there are right and wrong ways of doing this. By following the correct procedures, you can fulfill your responsibility to make sure this load gets to its destination safely. In this program, we review safe loading and unloading and the proper tie-down procedures for transporting equipment and material, such as the person transporting garden equipment, loading a track skid steer, or a large rubber-tired front-end loader. The goal is to help you transport safely. A piece of equipment tied down with a few ropes and secured with simple double knots to a truck, trailer, or deck is not a safe securement system. All components of a safe securement system are specifically manufactured with rated capacities to withstand the pressure of the equipment and the items you're transporting. You must know the rated capacity of the truck or trailer, the rated capacity of the tie-down points on the truck or trailer, how and where to position the load on the trailer, the proper load tie-down points, and the rated capacity of the hardware, including chains, binders, and hooks. Working together, these components make up a safe securement system. Many operators don't realize that many different vehicles of all shapes and sizes can be considered as transport vehicles. This includes everything from a truck tractor through to pickup trucks, regular trucks, enclosed vans, and even 2- and 4-wheeled sport utility vehicles. Any vehicle that's being used to transport cargo, whether it's a cat, an ATV, a load of lumber, or any one of thousands of things, is considered a transport vehicle. Whatever you're using to transport, you need to know how much you can carry, your vehicle's rated capacity to haul equipment or goods safely. This is also called the gross vehicle weight, or GVW. The GVW of your vehicle is the total mass or weight when loaded. This includes the total of the load, the vehicle, fuel, passengers, and the weight of the trailer tongue. For some vehicles, the GVW can be the manufacturer's rating, or it might be what your vehicle is registered to handle. In other words, it's dangerous and definitely illegal to haul more than the vehicle or trailer can handle. Trailers come in a wide variety of types and sizes and shapes, each designed to safely haul a load. How safe they actually are depends on the trailer's capacity and the effort made to properly secure the items being transported. Trailers should have manufacturer's tie-down points and structures built in to make securement easier and safer. These may include front-end structures, walls, floors, posts, and bulkheads, and such tie-down anchor points as D-rings. Regardless of the types of tie-down points or structures your trailer has, these must be able to hold the intended load and be of sufficient capacity to handle the road conditions that occur when the items are being transported. The rated capacity of the tie-down points should be in the trailer operator's manual. If you don't know, it's up to you to contact the manufacturer and find out. All trailers have a manufacturer's rated capacity for the maximum weight they can safely carry under normal conditions. The rated capacity is generally recorded on a data information plate. The load on the trailer must not exceed the maximum weight shown. Overloading a trailer creates stress on the deck and frame components, axles, wheels, spring suspension, and towing attachment points. Severe overloading also decreases braking efficiency and the steering control of the towing vehicle. The risks of overloading are compounded in severe weather conditions. If you can't find the data information plate, check the manufacturer's operator's manual or contact the manufacturer to find out the rated capacity. It's obvious you need the right trailer for the right load. If it can't handle what you want it to handle, don't use it. The dangers are too great. Okay, so you know your vehicle or trailer's GVW and you're certain it can handle the load you're carrying. Now it's time to do a walk around, a circle check. Walk around your vehicle and trailer to make sure everything's okay. Make sure you're well prepared before loading. Walk around the vehicle, trailer, and loading area and check out the following. Make sure low or flat tires and improperly working lights are repaired. Dangling hoses or wires are removed or secured. That the trailer or transport vehicle is on good firm footing. If one side suddenly sinks into the ground while loading, this could spell sudden disaster. Anchor points, lock pins, panels, and doors are intact. The trailer hitch has the proper rating for the load, and the safety chain should have a working clevis lock. Check that your breakaway system is functioning. Loose tools, timber, or equipment, loose panels, etc. are removed or secured. That all mud, snow, and ice buildup in the loading area and on the trailer bed is removed. And finally, ensuring that there are no overhead wires or obstacles in the loading area that could be a potential hazard. Getting into the habit of taking a few extra precautions before loading is well worth the effort. Some organizations may require documentation for their hazard assessment process. The loading and unloading process really depends upon what your cargo is and what conditions you're working under. You need to adjust your strategy to fit the circumstances. Obviously, site conditions for loading and unloading vary. When outdoors, weather conditions can change within minutes. Slippery surfaces from snow or mud, along with reduced visibility in severe weather conditions, can dramatically increase safety hazards. Weight and balance on the trailer must especially be considered before loading a piece of equipment like a backhoe. The weight of this machine and where it's parked on the trailer will affect handling, visibility, and overall safety during transport. Remember, the load on the trailer must not exceed the rated capacity. Guessing the load weight is not only risky, it's not smart. Overloading can cause stress on the transport vehicles and create major threats to safety. You must know the weight of the equipment you're loading. The size and shape of the equipment and items you're loading and unloading may create maneuvering and visibility limitations that make loading and unloading a challenge. If you're not sure about how to safely load or unload a piece of equipment, ask someone who actually knows how to do this. It's not as easy as it appears, especially in bad weather conditions. Get someone who is qualified to show you how this is done. Okay, you've placed your equipment or materials where they should be on the back of your truck or trailer, and you've double-checked your straps and chains. The next step is to make sure you secure this load correctly. For equipment, best practices suggest using at least 4 individual tie-down points to restrain the machine from moving in all directions. The tie-downs also need to consist of a combination of chains or wrappers, binders, and hooks, depending upon the weight of the machine. For loads over 4,536 kilograms, 4 individual tie-down points are required. A direct tie-down is anchored to a direct tie-down point on the transport trailer and equipment at all 4 corners, pulling in 4 separate directions. This will prevent the load from moving forward and back, side to side, and up and down. Regulations also require each tie-down to be attached and secured in a manner that prevents it from becoming loose, unfastening, opening, or releasing while the vehicle is in transit. Whatever you do, do not tie knots and chains to shorten them. Making or leaving a knot in a chain is creating a potential breaking point or a point where the chain can loosen. Aggregate Working Load Limit, AWLL. The aggregate working load limit is the sum of the working load limits of each device used to secure an item on a vehicle. If there are 4 separate tie-down points, the AWLL is the rate of all 4 added together. The aggregate working load limit of any securement system must exceed 50% of the weight of the equipment being secured. For example, if the equipment weighs 2,000 kilograms, then the AWLL capacity must be greater than 1,000 kilograms. This is required by law. To clarify, in this example, each component of the securement system has a capacity of 300 kilograms. As a result, the total working load limit of the 4 tie-down points is 1,200 kilograms. This exceeds the weight of the equipment by 200 kilograms, more than 50% of the load. Remember, the rated load limit is usually marked on the component or provided in the manufacturer's operator's manual. If not, contact the manufacturer. In order to determine how well the components of your securement will work together, you must know each component's working load limit, or WLL for short. The working load limit is the maximum load that may be applied to a component of a securement system during normal service. The working load limit for a tie-down is the lowest limit of any of its parts or the anchor points it's attached to, whichever is less. Every device contributes to the aggregate working load limit of the securement system. The component manufacturer usually assigns the WLL. A piece of grade 7 chain may be marked with a 70 or 700 in accordance with the standard of the National Association of Chain Manufacturers. The standard then gives the working load limit for that piece of chain, depending on its size. Carriers are recommended to use components that are rated and marked by their manufacturer. In that way, the carrier, driver, shipper, and inspector can all verify that the proper equipment is being used for the job. In all cases, whether it's a box, piece of equipment, a snowmobile, or a load of lumber, your tie-downs must be able to maintain pressure downward in order to ensure the load you are transporting can withstand a minimum amount of force in any direction, forward, rearward, sideways, or upward in all driving conditions. Some tie-downs are attached to the cargo and provide direct resistance to restrain the cargo from movement. Some tie-downs pass over or through the cargo, creating a downward force that increases the effect of friction between the cargo and the deck of the vehicle. This friction restrains the cargo. The rule of thumb is to use one strap for any load that weighs up to 500 kilograms and are up to 1.52 meters in length. Anything over 500 kilograms and between 1.52 to 3.02 meters in length needs 2 straps. Anything longer than 3.02 meters requires a strap for every additional 3.02 meters. You need to check the driver's handbook on cargo securement for the standards required for any specialty loads like prefab building materials, pipes, and culverts. Chances are you use a trailer to transport your ATV, and that trailer is a small flatbed you tow behind your car or truck. The last thing that you or anyone wants is to have a four-wheeler come off a truck or trailer when you're driving down the road. When tying down an ATV, use at least 4 separate tie-down points, one for each side of the ATV. Most trailers have several hooks and areas to secure a strap, so look for the closest one and hook the strap in securely. Once all the straps are secured and tightened, take the excess strap and secure it so that it doesn't hang loose. This will prevent the excess from dangling below the trailer and possibly getting caught on something. To test the tie-down job, slightly push the ATV in each direction. There should be no excess sliding of the ATV, and the trailer should move just as the ATV moves because they're securely fastened to one another. It's doubly important to make sure individual pieces in a load don't slide out or come loose. You could be held liable if anything flies off the back of your trailer or truck. And in case you're wondering, the cab shield or headache rack on a light truck or pickup is not considered part of a securement system. Don't be tempted to use this rather than the deck as the anchor for your tie-down. Most racks and vehicles like this are not secure enough to hold a heavy load. Once the equipment is safely loaded and tied down, give it one final inspection, making sure that all legal warning devices are in place and that all your running lights are in proper working order. Consider the impact of flying debris on other people on the road. Before you drive, check for debris like stones and dirt. Carefully check for other loose objects like tools, chains, binders, shovels, or pieces of wood on the trailer. An item such as a hand shovel bouncing off your trailer at 60 kilometers an hour and hitting the windshield of a vehicle behind you can cause a fatal accident. And be doubly sure that your load isn't too high. The quickest way to check this is by using a good tape measure or a pole marked in meters. A few minutes checking the height of your load can save you hours of grief. Now, once your load is secure, remember to buckle up and drive safely. No matter how secure this load is, reckless driving can dislodge it. Then stop periodically to inspect the load, trailer equipment, and securement devices. Regulations say drivers must perform minimum trip inspection requirements before driving, within the first 80 kilometers, and after 3 hours or 240 kilometers, whichever happens first. If the machine has to be set off on or near a busy public roadway, special consideration has to be made for the passing traffic. Use traffic cones or other high visibility warning devices. And when you stop, be sure to park in a safe, flat area. Shut off the vehicle and remove the key. Check that equipment and items have not shifted, that tie-downs are not damaged or weakened, and they're not loosened or undone. Make the necessary adjustments. Law enforcement will be the first to tell you that ignorance is not an excuse. Remember, all drivers have the shared responsibility to protect everyone on or near the road. As you've seen, load securement is not a matter of a few straps or ropes. Any load of any size is a potential hazard on the road. It's your responsibility to make sure this piece of equipment or load stays where it's supposed to stay. If you don't do your job will bounce back to bite you, and hard. It doesn't take a lot of imagination to figure out what this machine, a load of plywood, or a flying rake can do to the vehicles behind. Load securement is everyone's securement. Don't take risks. Do the job right.
As you just watched, load securement is critical to driving safety. For example, this news article shows what happens when a 2-meter-long piece of metal fell from a tow truck and hit the windshield of the car behind it. Carrier profile. The carrier profile is a report card of the carrier's compliance to, on-road, and administrative requirements and performance based on information collected from across Canada. The carrier profile is a monitoring record for the company commercial vehicles. It contains the following information: carrier information, conviction information, CVSA inspection information, collision information, violation information, and monitoring information. Alberta Transportation rates the company by a risk factor, otherwise known as an R factor, based off the levels of risk in all the areas of the profile. The R factors range from 0 to 4. 4 is the highest risk and they consider that an extremely unsafe company. When the company reaches an R factor of about 2, it is possible that they will complete an audit. It is ideal to try and keep the R factor at 0. Truck drivers' time. Drivers are required to give time for the day. Their time must match the driver's logs. It is important that their time goes on the correct ticket for the correct day. Transportation auditors audit the driver logs to their payroll records. This is why the time needs to be accurately recorded on the right day. Transportation will also audit the fuel records to the driver's logs. Monthly safety meetings. Monthly safety meetings are to be held on the second Wednesday of the month. Monthly safety meetings are distributed to supervisors every month to review with their crews. Be sure to inform your inspector ahead of time. Competencies and on-the-job training. Competency and on-the-job training is required by legislation. Competency assessments start from senior management and work down the organizational chart. Supervisors will be responsible to complete the competency and on-the-job training for their crews. Terra Firma utilizes competency assessment forms that serve as a checklist for the trainer to assess the worker. QC training must be provided to all key personnel involved in QC activities. In this training we will review the requirements of a project's job file, in addition to important sections of the QC manual. This includes safety, scope, quality control, welders, NDE certifications, NDE interpretation reports, piping punch lists, examination checklist, non-conformance reports, records of calibration, pressure testing, line pipe, crossings, provincial QC, piping compliance plan, mill test reports, as-builds and weld mapping, landowner releases, change management, and bolt torque record. A. Safety. Section A of the job file is dedicated to safety paperwork. It is here that you will place all documents related to safety on the job, including hazard assessments, safe work permits, ground disturbance permits, and more. Blank job file packages come with blank copies of the following for you to fill out as necessary. Emergency response plan. Work site inspection. Ground disturbance checklist. Power line checklist. Initial incident report. Witness statement report. And vehicle accident report. B. Scope. Section B of the job file is dedicated to contract review. This section must be completed prior to the job beginning, and must be reviewed and signed by both the supervisor and the inspector at the start of the job. This is important so that both the manufacturer and the client understand what is required for the job before execution. In this section, you will find blank copies of Contract Review, page 1. Contract Review, page 2. Contract Review, page 3. And Document Transmittal. On page 1 of the Contract Review, you must define the code of construction. If it is an ASME B31.3 job, write the date of the latest code edition as well as the fluid service category beside it. If it is a CSA Z662 job, write the date of the latest code editions as well as the fluid service category beside it. If there are both codes involved in the project, fill out both sections. On page 2 of the Contract Review, you must define responsibilities on the job. Data reports are signed by the two people directly responsible for construction of the project. AB 81 is only required if the system is greater than 500 liters. The lot size must be set before the project begins. What is a lot size? A lot is a predetermined scope within the project that will be completed and then examined to ensure there are no defects. A lot can be each day, each spool or drawing, a certain number of welds, or even the entire job. For example, Lot 1 is completed on this day as shown by the arrow. The RT reports showing a date when the lot was completed, or past that date, must account for the RT required by the engineering design. Lot sizes must be established prior to the start of a job. RT must be done on or after the date a lot is completed. And RT done for Lot 1 cannot be applied to any future welding on new piping. For example, lot number 2, 3, etc. Another example, if a repair is found within the lot, then 2 traces must be shot for the same welder within that lot. If there is a defect in one of those 2 traces, then 2 more traces must be shot within the lot. If there is a defect in any of those traces, then the entire lot must be reshot. Another example, a weld defect is discovered by RT. This means that 2 traces are required of the same kind of welds, by the same welder, examined by the same RT method, and from the same lot. If the examination is acceptable, repair the defects found earlier and re-examine by the same method. If re-examination is acceptable, close the action. If defects persist, 2 more tracer shots are required of the same kind of welds, by the same welder, examined by the same RT method, and from the same lot. If the examination is acceptable, repair the defects found earlier and re-examine by the same method. If re-examination is acceptable, close the action. If defects persist, shoot or repair the entire lot. Repair all defects discovered so far or replace all parts of the lot which were welded by welders whose welds were radiographed above and progressively found defective up to this point. All repairs must be re-examined and pass subsequent RT. It may seem easiest to choose the entire job as a lot, but this means that if you have 2 failed traces, you must reshoot the entire job. This may be fine for small jobs, but for larger jobs, we may want to establish a smaller lot size. Lot size must be agreed upon between the supervisor and the inspector at the beginning of the job and recorded on the contract review form. If there is a failed weld, there must be clearly labeled tracer shots on the NDE report. Last example. Lot size is established as each spool. First spool is fabricated and passes all NDE. Proceed. Second spool is fabricated and has 1 rejected weld by welder X. Because of this, NDE shoots 2 random traces on welder X on that same spool and finds one of them defective. Again, because of this, NDE shoots 2 more random traces on welders X on the same spool and both pass. Re-examination is acceptable and action is closed. All defective welds are repaired and reshot. For pipeline QC, this section also has the inspection and test plan. The main items that need to be specified in an inspection and test plan are the item that will be checked, inspected, or tested, the technical document which contains the acceptance criteria. This criteria will determine whether the inspection is a pass or fail. All listed forms must be filled out and filed in the QC binder. The type of inspection required, for both terra firma and the client. This utilizes a series of codes. HRSW and not applicable. H stands for hold point. The party has to perform this check and it needs to be successful in order to proceed to the next stage of the construction. R stands for review point. The party has only to review the record or document that the check has been done and it passed. S stands for surveillance. General attendance at site. No signature required on the inspection request or its accompanying documentation. W stands for witness point. The client has to be informed that a test is being performed, but its presence and signature is not obligatory to move on to the next stage. NA stands for not applicable. No requirements for this particular activity. The name of the representative for both terra firma and the client, as well as the date. This signifies that the people signing have performed the necessary inspection as outlined in the ITP. The ITP will be submitted to the client along with all relevant documentation as part of the QC package. On page 3 of the contract review, you must check the copies of items requested by the client upon completion of the job. Please note that on all pages of the contract review, pages 1, 2, and 3, both the supervisor and the inspector must sign and date at the bottom. C. Quality control. Section C of the job file is dedicated to general quality control information. There is nothing to fill out or sign in this section. In this section, you will find terra firma's Certificate of Authorization Permit, Weld Procedures TFR1N, Rev 2, Weld Procedure TFR-PL2, Rev 2, Weld Procedure TFR-PL4, Rev 0. Terra firma's Certificate of Authorization Permit gives terra firma permission to perform construction, repair, and alteration of ASME B31.3 process piping in both the shop and the field. Terra firma is not allowed to work outside this scope. This means that only pressure piping may be built, repaired, or altered. No pressure vessels allowed. As a general overview, WPS TFR1N, Rev 2, is terra firma's ABSA-approved WPS for welding above-ground piping. Is a low-temperature procedure, so it is tested and acceptable for temperatures down to -50 degrees Fahrenheit. And is not used on pipelines. As a general overview, WPS TFR Place 2, Rev 2, is an underground procedure, as it is only notch toughness tested to -18 degrees Celsius. And is a pipeline procedure applicable to only 8-inch and higher in diameter with a wall thickness of 4.0 mm to 15.9 mm. As a general overview, WPS TFR Place 4, Rev 0, is an underground procedure, as it is only notch toughness tested to -30 degrees Celsius. And is a pipeline procedure applicable to only 2-inch to 12-inch in diameter with a wall thickness of 1.5 mm to 7.2 mm. These overviews of the weld procedures are not exhaustive. Supervisors are expected to read and be familiar with every weld procedure so that they be used properly. D. Welders. Section D of the job file is dedicated to welding. There are 4 forms that must be completed prior to commencing welding. WPS approval form, welder log, welder declaration, and welder qualification summary. The WPS approval form must include project information, nominal pipe size of all pipe, wall thickness of all pipe being used, material grade of all material being used, the client approved weld procedure. Put a check next to the approved procedure. The welder log must include welder name, ABSA file number and symbol, process, welding procedure, P number, F number, position, maximum deposited weld metal thickness, minimum pipe diameter, and expiry date of performance qualification card. This log must include every welder on the job. This information must be logged prior to any welding taking place. A copy of the welder's tickets must be included with this log. It is the supervisor's responsibility to include them and check that they are valid. Every welder on the job must sign a declaration prior to welding to state that they understand the weld procedure they have been given and they will follow it. This form must also be signed by the supervisor on site. The welder qualification summary is to be filled out for each welder, stating all of their welding credentials and information. These forms accompany the copy of the welder performance qualification ticket that you copy and place in the job file. Any welder working on our projects must not only have a performance qualification card valid to within 2 years, but they must also have welded within the past 6 months. Welders who have provably welded for terra firma resources are acceptable. New welders must either provide proof from a previous employer, or they must be parameter tested and documented in the QC package. If in doubt, please contact the office. NDE certification. Include CGSB and I exams for all NDE technicians on your job. Include the CGSB and I exam for the Level 3 technician for the NDE company as well. For ASME B31.3, all NDE technicians must have an SNT certification. This is the American version of the CGSB. Technicians must be, at a minimum, a Level 2 in the method they are performing. Make sure that they are not expired. Also make sure their I exams are less than 1 year old. NDE interpretation reports. ASME B31.3 specifies that only companies with an ABSA-approved certification is allowed to manage the NDE for a given project. That means that, while the client's representative typically hires the NDE company directly, it is the responsibility of terra firma to direct the NDE personnel and validate their results as being compliant. The NDE instruction sheet is used for this purpose. This form is to be filled out prior to any NDE being performed so that the technicians know specifically what they are shooting, to what code, to what lot size, and to ensure they have the proper certifications and valid I exams. Terra firma is also expected to review and approve NDE reports and film. This is not meant to be an extensive and in-depth technical review of the NDE results. The purpose is simply to show due diligence by checking that the report is complete, such as the name and address of the NDE subcontractor, date, code of construction, code edition, signature of the NDE technician, qualifications of the technician, terra firma job number, etc. All of the joints identified by the RT drawings and marked on the piping were radiographed. And the interpretations are properly explained. Reports are to be signed to signify they were reviewed. For the NDE film, simply review important features, such as the name of the NDE subcontractor is indicated. The date of the radiograph is indicated. Weld joints are identified. Density is acceptable. In other words, the film is readable and is not too dark or too light, and there are no clear doubts as to interpretations of the technician. If doubt exists, it goes to the level 3 of the NDE subcontractor. Sign the film package to indicate proof of review. Examination checklist. Section H of the job file is dedicated to the pressure piping examination guide. This guide is a checklist that must be gone through prior to hydrotesting. Once all items on the list have been inspected prior to testing, the supervisor must sign and date it. Non-conformance reports. Non-conformance reports are not a negative thing and should be utilized as needed. They are an important tool that is used to identify potential problems or trends that can be rectified in one's own QC program. Properly identifying and tracking a non-conformance is the only way that a QC program can improve over time. If one arises, contact and submit to the office immediately so that we may ensure that it is properly rectified before proceeding. Record of calibration. Section J is dedicated to calibration reports for hydrotesting instruments. All calibration records for pressure gauges and pressure and temperature recorders used for hydrotesting must be placed in this section. Note: as per section 4.1.4 of QP12 of the QC manual, for or any test, either 2 calibrated pressure gauges must be used, or 1 calibrated gauge along with 1 pressure recorder can be used. Note: also, as per section 4.1.4 of QP12 of the QC manual, for or any test, pressure gauges must be between 1.5 times and 4 times the test pressure. For example, if a test is 100 psi, the gauge must be within 150 psi, or 1.5 times 100, and 400 psi, or 4 times 100. K. Pressure testing. Section K is dedicated to pressure testing. In this section, the following can be found: hydrostatic testing procedure, pneumatic testing procedure, and hydrotest package, including pressure test report. Note: pneumatic testing is dangerous and may not be completed without permission. For every hydrotest on the job, fill out a unique hydrotest package. Fill out the information on the cover, including job number, client, test number, date, LSD. On the pressure test report, fill out job information, spool number, line number, code reference, specification, pipe material, pipe size, wall thickness, P&ID number, test number, minimum, maximum, and actual test pressure, test medium, test temperature, strength test duration, leak test duration, percent buried versus percent exposed. Deadweight gauges information, including range, serial number, manufacturer, calibration date, and certificate copy. Recorder information, including range, serial number, manufacturer, calibration date, and certificate copy. Temperature recorder information, including range, serial number, manufacturer, calibration date, and certificate copy. Both the supervisor and the client inspector must sign the bottom. On the pressure report, record in intervals: time, pressure, ambient temperature, pipe wall temperature, ground temperature, if applicable. All pressure testing charts must be placed in the job file with these documents and signed by client representative and supervisor. All charts must have locations, times, and serial numbers for gauges recorded on them. Reference drawings being tested must be recorded on your pressure test report. L. Line pipe. Section L of the job file is dedicated to line pipe. There are no forms to fill out or documents to sign in this section. Place pipe tallies in Section L for the delivery of pipe. M. Crossing agreements. Section M of the job file is dedicated to crossing agreements. There are no forms to fill out or documents to sign in this section. Place all crossing agreements and reports, as well as any drill reports if applicable. N. Provincial QC. Section N is dedicated to data reports for CSA Z662 and ASME B31.3. It includes Z662 Pressure Piping Construction and Test Data Report, ABSA Pressure Piping Construction and Test Data Report AB83, ABSA Completion of Construction Declaration. For all scope that is CSA Z662, the Z662 Pressure Piping Construction and Test Data Report must be filled out. On this form, you must fill out owner and location, WP number of weld procedure, drawing, revision, or line number, fluid, design temperature, pressure test pressure, test medium, pipe material specification and grade, corrosion allowance, pipe size and schedule, flange material and rating, post-weld heat treatment preheat temperature, and NDE percentage. Both the supervisor and inspector signs the bottom. For all scope that is B31.3, the ABSA Pressure Piping Construction and Test Data Report must be filled out. On this form, you must fill out owner and location, WP number of weld procedure, drawing, revision, and line number, fluid, design temperature, pressure test pressure, test medium, pipe material specification and grade, corrosion allowance, pipe size and schedule, flange material and rating, post-weld heat treatment preheat temperature, and NDE percentage. The second page of this form must be signed by the terra firma representative responsible for the construction as well as the client inspector. If the construction holds greater than 500 liters, then the ABSA completion of construction declaration, AB81, must be completed. If the system contains less than 500 liters, then it does not have to be registered with ABSA. O. Piping Compliance Plan. Section O is dedicated to the Piping Compliance Plan. This document lists the activities involved throughout the project and must be signed and dated by both terra firma's supervisor as well as the client's inspector as each activity is completed. Under the Required column, the applicable activities are checked under Yes or No, depending on if they are required or not. Under the ITP requirements, or Inspection and Test Plan requirements, the inspection requirements must be checked for each activity. H stands for Hold, and it means that construction must stop at that activity until both the terra firma supervisor and inspector have verified satisfactory completion. W stands for Witness, and it means that the activity must be witnessed by the client's inspector. V stands for Verify, and it means the client's inspector must verify that the activity was completed. E stands for Examine, and it means that client's inspector must examine the results of the activity. And the last stands for Acceptance, and it means that the activity must be accepted by QA or engineering prior to continuing. By the end of the project, all of the activities will have signatures and dates beside them from both terra firma supervisor and client inspector. P. Mill test reports. Material receiving is important for a comprehensive QC package and the first line of defense to spot defective fittings. Please ensure that the material receiving list is complete and matches both the MTRs and the as-built drawings. Always include all packing slips. This makes it easy to locate missing MTRs, as the order number can be provided to the supplier. Heat numbers labeled on as-built drawings must be checked to make sure they are accurate and that the MTR is present and correct prior to construction. Heat numbers must match the material receiving list. The supervisor must locate each MTR for every heat number on the as-built drawings. For each MTR, they must highlight the heat number on the MTR and initial and date the MTR. When reviewing these packages, it should be an easy and accurate process to locate the MTR for any given heat number on your as-built. Include supplier packing lists in the job file for additional traceability. Q. As-builds and weld mapping. Section 8.4.13.1 of the current QC manual lists all information that must be included on the spool sheets we develop. On the previous isometric paper, this information is included at the bottom of the page and on the right side under Design Parameters. This section is important for staying in compliance to terra firma's QC manual and ABS's requirements. This isometric paper is missing 3 requirements: fluid service category, temperature and holding time for post-weld heat treatment, and joint design details. New terra firma isometric paper has been designed with the QC manual's requirements in mind. The intent is to include all requirements as per the manual, while making it simpler and easier to fill out by using blanks and checkboxes. It contains all of the information required on our drawings as per our QC manual. Material specification, grade, dimensions and schedule, type and rating. Design pressure and maximum, minimum design temperature of system. Code of construction including addition and for ASME B31.3 process piping and the fluid service category. The type and extent of non-destructive examination required. Preheat and post-weld heat treatment, temperature and holding time, if applicable. Test pressure and test medium. Construction, repair or alteration details, supports, etc. Welding procedure specification and joints details and dimensions. Joint design details. And any additional requirements. Ensure that all spool drawings reference the owner-supplied engineered drawing under drawing information. This specific isometric paper does not necessarily need to be used. Any paper or medium, for example, Acorn, Bluebeam, etc., can be used, so long as it displays all of the requirement information as per section 8.4.13.1 of the QC manual. Please remember to fill out all required design information when developing your drawings. Another important addition are the issued for construction and client approval boxes. When no design drawings or spool drawings are supplied by the owner and the spool drawings are prepared by the contractor, documented approval shall be received from the owner to ensure that the design, material, fabrication, NDE, PWHT, hydrotest and any other requirements are correctly specified. While the current method of obtaining drawing approval is through the piping compliance plan, ABSA has also recommended that clients could sign off approval on spool sheets that display all of the design information. Additionally, all drawings must be issued for construction prior to release for construction. This is a form of document control that ensures that the proper, complete drawings are on the shop floor for construction. A spot has been included in the new isometric paper for the drawing to be issued for construction. Please sign and date the spool sheets when they are released for building. The QC manual states that a drawing list must be maintained indicating the drawing title, number and revision, copies issued, and the name of the person to whom they were issued. This is a method of document control to ensure that all recipients have the latest and proper copy of the drawings issued. By tracking which drawings are released and to whom, we can recall and destroy them if there is a superseded copy. These drawing lists are located in Section Q of the Quality Control Packages. Please fill these out to control drawings during construction. R. Landowner releases. In Section R, there are no documents to fill out and sign. Place here any landowner release documentation if applicable. S. Change management. Section S is dedicated to change management. In this section, the following can be found. Scope for change management procedure. Field change notification form. This form is to be completed if any changes to scope or specifications occur. Ensure to get the client's approval and signature prior to starting any changed work. Section T is dedicated to bolt torquing. In this section, the following can be found. Bolt tightening and torquing procedure. And bolt torque record and spool and flange unobstruction verification. This procedure only applies upon client's specifications. In the bolt torque record, fill out the information on the bolt up taking place. Include joint ID number, first pass, second pass, third and fourth pass. Both the terra firma supervisor and the client's inspector signs the document. Now that we have reviewed each section of the job file, please ensure all signatures are completed prior to delivery to the office. This includes both the client and yourself. Obtaining signatures after the fact delays the turnover process. Quality control manuals are controlled documents, issued to QC inspectors within the company, to be taken care of and returned upon issuance of the latest edition. The following controlled manual list shows who has which manuals. Please note that, as per Section 5 of the Quality Control Manual, the company of terra firma resources is small and, as such, each of the personnel may perform more than one function and have several responsibilities. The Quality Control Manual delineates superintendent and quality control inspector into two different roles. However, these roles are typically a dual role of the superintendent on small jobs. On larger jobs, a dedicated quality control inspector may be assigned. For most jobs, however, the supervisor must perform the role of quality control inspector as well. All personnel performing quality control activities need to have an evaluation and training record filled out and signed by their supervisor. All supervisors must also be trained and have an evaluation and training record filled out and signed yearly. Upon completion of this training, contact either the office or your immediate supervisor to receive your evaluation. Return all signed evaluations to the office. As a final topic in this training, we will review how to perform weld parameters. It is the responsibility of the supervisor to ensure welding is being completed in accordance with the approved welding procedure. This must be accomplished by recording and checking the welder's parameters. In these slides we will review this procedure so that it can be effectively performed in the field. Begin by preparing the multimeter. Insert the red test lead into the positive V terminal and the black test lead into the negative COM terminal. The colors will match up. Plug the red lead into the stinger welding cable and the black lead into the ground cable. Place the clamp around the stinger welding cable. Before testing the first pass, record the preheat temperature of the pipe as well as the rod size. Rod size in terra firma's pipeline weld procedures are in metric. To determine a rod size from inches, simply use the following formula. Rod size in inches multiplied by 25.4 equals rod size in millimeters. For example, what is the metric rod size of 1/8 of an inch? 1 divided by 8 times 25.4 equals 3.2 millimeters. What is the metric rod size of 5/32 of an inch? 5 divided by 32 times 25.4 equals 4.0 millimeters. To begin testing the first pass, start the timer when the welder begins. When the welder stops, stop the time and record it. While the pipe is being welded, record as many different readings of voltage and amperage as you can. To read voltage, turn the dial on the multimeter from off to V depending on the multimeter. Alternating current, represented by a squiggly line, and direct current, represented by a straight line, may be separate on the dial or may be combined. When recording weld parameters, we want to be on the direct current setting. If they are separate on the dial, select the V with the straight line. If they are combined on the dial, you can switch between the two typically by pressing the cell button until the straight line is shown on screen. Note: if you find the readings are displaying incorrectly, or MV is showing up instead of V, it is because your probes are not making proper contact with the stinger and/or grounding cables of the welding machine. Make sure they are properly inserted. To read amperage, turn the dial to A on the multimeter. Again, depending on the multimeter, alternating current, represented by a squiggly line, and direct current, represented by a straight line, may be separate on the dial or may be combined. When recording weld parameters, we want to be on the direct current setting. If they are separate on the dial, select the A with the straight line. If they are combined on the dial, you can switch between the two typically by pressing the cell button until the straight line is shown on screen. The time you recorded will most likely be in seconds. You must convert the time in seconds to time in minutes using the following formula. Time in seconds, divided by 60, equals time in minutes. For example, the time recorded for a pass is 45 seconds. 45, divided by 60, equals 0.75 minutes. Another example. The time recorded for a pass is 1 minute and 16 seconds. 1 minute and 16 seconds is equivalent to 76 seconds. 76, divided by 60, equals 1.27 minutes. Last example. The time recorded for a pass is 1 minute and 4 seconds. 1 minute and 4 seconds is equivalent to 64 seconds. 64, divided by 60, equals 1.07 minutes. Use a tape measure to record the length of the weld in millimeters. Determine the travel speed using the following formula. Travel speed equals distance in millimeters, divided by time in minutes. For example, the weld length is 300 millimeters and the time it took to weld was 0.75 minutes. What is the travel speed? 300, divided by 0.75, equals 400. The travel speed is 400 millimeters per minute. Another example. The weld length is 340 millimeters and the time it took to weld was 1.27 minutes. What is the travel speed? 340, divided by 1.27, equals 268. The travel speed is 268 millimeters per minute. Last example. The weld length is 290 millimeters and the time it took to weld was 1.07 minutes. What is the travel speed? 290, divided by 1.07, equals 271. The travel speed is 271 millimeters per minute. Determine the heat input using the following formula. Heat input equals amps times volts times 0.06 divided by travel speed in millimeters per minute. For example, the recorded amperage is 100 amps, the recorded voltage is 30 volts, and the travel speed was 300 millimeters per minute. What is the heat input? 100 times 30 times 0.06 divided by 300 equals 0.6. The heat input is 0.6 kilojoules per millimeter. Another example. The recorded amperage is 120 amps, the recorded voltage is 26 volts, and the travel speed was 320 millimeters per minute. What is the heat input? 120 times 26 times 0.06 divided by 320 equals 0.59. The heat input is 0.59 kilojoules per millimeter. Last example. The recorded amperage is 138 amps, The recorded voltage is 33 volts, and the travel speed was 400 mm per minute. What is the heat input? 138 times 33 times 0.06 divided by 400 equals 0.68. The heat input is 0.68 kilojoules per millimeter. Check the amps, volts, travel speed, and heat input against the requirements outlined in the weld procedure. This is shown on the screen under Table 1. Make sure the values are within the range shown in the table. The volts and amps will fluctuate quite a bit, so you can judge where they land. Travel speed and heat input will not fluctuate. If any of the numbers do not fit within the range, repeat the test. Let's do an example. The welder welded a root pass using a 4.0 mm welding rod. During this pass, you recorded the amps at 145 and the volts at 33. The travel speed was 235 mm per minute and the heat input was 1.22 kilojoules per millimeter. Do these parameters pass? Look under the amps column on the line next to root pass and 4.0 mm rod size. The range shown is 100 to 150. Since our amp reading of 145 falls within this range, it passes. Look under the volts column on the line next to root pass and 4.0 mm rod size. The range shown is 24 to 34. Since our amp reading of 33 falls within this range, it passes. Look under the arc speed column on the line next to root pass and 4.0 mm rod size. The range shown is 199 to 406. Since our travel speed of 235 mm per minute falls within this range, it passes. Lastly, look under the heat input column on the line next to root pass and 4.0 mm rod size. The range shown is 0.51 to 1.16. Since our heat input of 1.22 kilojoules per millimeter falls outside this range, it does not pass. Even though the weld passed the amps, volts, and travel speed, it did not pass the heat input. Therefore the weld fails. Final exercise. Perform the following calculation and determine if the welder passed on his or her route based on WPSTFRPL2. This is the root pass, and the rod size used is 5/32 of an inch. The range of amps were recorded with the average being 120, and the range of volts were recorded with the average being 30. It took 45 seconds to perform the pass, and in that time the welder traveled 290 millimeters. Did the welder pass? Please feel free to pause the video and perform all checks and calculations before proceeding. Check your answers against the results in the following slide. For the rod size, 5 divided by 32 times 25.4 equals 4.0 millimeters. For the minutes, 45 seconds divided by 60 equals 0.75 minutes. For the travel speed, 290 millimeters divided by 0.75 minutes equals 387 millimeters per minute. For the heat input, 120 amps times 30 volts times 0.06 divided by 387 millimeters per minute equals 0.58. Look in the line beside root and 4.0 mm rod size. 120 amps falls within the range of 100 to 150, so it passes. 30 volts falls with the range of 24 to 34, so it passes also. 387 millimeters per minute falls within the range of 199 to 406, so it also passed. Lastly, 0.58 kilojoules per millimeter falls within the range of 0.51 to 1.16, so it passes also. So, did the welder pass based on these parameters? Yes, they did. You will need to complete this process again for the hot pass, fill, and cap to fully qualify the welder to the WPS being used. This concludes Terra Firma's supervisor training. Thank you for your time, attention, and active participation.